This is lesson 7, day 1, where today we're going to talk about reasoning. We're going to talk about creating little worlds that we're going to make arguments for. And this is going to be interesting for the fact that some of us are going to get these right away, and some of us are not going to, because we're going to struggle with the fact that we can do things in our world that we make up that you can't do in the real world. Like if I said all cows fly. In the real world, cows don't fly, okay? Okay, you put them on a plane. Oh, they're fine. No. I'm saying all cows can fly. If I said Mel is a cow, then what would logically think about Mel?
She has a name.
Okay, all cows can fly. Mel is a cow.
She can fly.
Then Mel can fly. That seems like a logical progression, right? So what we're going to do is we're going to try to use logic to show that things are either valid or invalid. So our first slide here is going to talk about a couple different techniques. The first technique is inductive reasoning. It's the process to try to find a rule. So if I gave you a progression of numbers, like maybe even just 1, 2, 3, 4, we can inductively reason to try to find the next term. Try to find the rule. What's the rule, do you think, that's happening between these numbers? Going up by 1. Add 1. So then the next number will be 5. So to formulate is to induce. We are inducing a formula of add 1. We're formulating. So inductive reasoning. Okay? That is inductive reasoning. The other half, or the other part, is called deductive reasoning, and it's the process of using a rule once it's already been there. So you use a set of rules, rule after rule after rule, to come to a conclusion. If I said, like for math at least, f of x is 2x plus 1, we could use the rule to find out what our number is. If I said x equals 1, can you find y? Or f of 1? What's f of 1? Using the rule, it's 2 times 1 plus 1, which is 3. So I deductively use the rule to get 3. And there are two starred things here that kind of you have to kind of just accept because they work. That if a rule is false, but it's used properly, then the conclusion reached can be false. So if a rule is false and used properly, like a cow can't fly, right? That's a false premise. Premise means statement, okay? So if it's a false statement, cows can't fly, but I said Mel was a cow, therefore Mel flies. Well, Mel can't fly in the real world, but according to that particular argument, it flows, it works. Okay, the study of logical reasoning is the study of the proper use of rules. The truth or falsity of the rule is not a consideration. I could care less that people are going to argue with me that cows don't fly. But as soon as I state it, I just built a small little world, my own reality, right? Where all cows can fly. So you have to reject your reality and substitute mine. Oh, what's that say? Mythbusters. I reject reality and I substitute my own. I think that's one of the phrases he says. I think that's Adam. It's a good one. Because it has to do with this. don't accept it because you think they're seeing things happen. If someone states something, we're going to assume it's true for these. So, now we got a couple more definitions here. Guys, we don't have to write everything down. Take some bits and pieces from this. The first word is called a syllogism. It's a formal reasoning process based off of premises. Premises are statements, guys. There are two premises and a conclusion. I have already shared one. All cows can fly. Mel is a cow, therefore Mel can fly. That is a syllogism. It's made up of two premises. The first premise, all cows can fly. The second premise, which is our minor premise, identifies Mel to be part of the group. And the conclusion would be that since Mel is part of the group, she has to possess the skill or the characteristic of that group, which is flying. So for a syllogism to be valid, you have to have a major premise that states a group has a trait, a minor premise that puts someone or something into the group, and then the conclusion naturally should follow that if you're part of a group that has a trait, then you should also have that trait. Does that not make sense? Yeah. That is a valid argument, as the last statement says. If a group has a trait, the argument, guys, format again is some group has a characteristic. Wait, guys. Wait. So, before we got kind of distracted there, a valid argument puts a group to have a characteristic. It puts somebody in the group, and then makes the statement that because they're in the group, they will have the characteristic. If, guys, there is any deviation from that flow, I'll call it a flow, then it would be an invalid argument. So, going back to my statement about cows. All cows can fly. Sally is a bird. Sally can fly. Is that a valid argument or an invalid argument? According to the rules, that is an invalid argument. Now you're thinking, whoa, wait a minute. But in the real world, if you're a bird, you fly. But there could be a reason. Maybe she doesn't. Maybe it's an ostrich.
Broken wing.
Maybe it's broken wings. Maybe born that you can't fly, right?
Maybe
So
she's a squirrel.
here's the thing. No, it said if she was a bird. Okay, listen, guys. This is the most difficult part about this, is that we want to bring in our worldly thoughts and things into this. We have to look at only the fact that you only know if you're a cow, then you can fly. Nothing else you know. So anything to the contrary to that is an invalid argument. Okay? So, guys, I'm going to go back and talk about that universal affirmative, that major premise. To be a universal affirmative, there is no question about everybody in the group. You cannot have a universal affirmative that says all cows, except for, this one, can fly. It has to be an all statement, or if it is a blank, then it does do blank. There's no wiggle room for there. Universally means everybody. Everything in that category. So, this is that format I was talking about. It's right here. We have a major premise that states the group has a characteristic. The minor premise that you try to state that somebody or something is part of the group. And therefore, the conclusion that the person also has the trait. Any deviation would be an invalid argument. We're just going to cover these 3 arguments today before we get our homework. Tomorrow we'll pick up on doing more of these arguments and then learn some of the skills that way they start to get a little tricky for us. And there's ways to deal with it to make them less tricky. So number 1, all men are mortal. Mr. Konchak is a man.
You don't have to write those down.
Therefore, Mr. Konchak is mortal. Is that a valid or invalid argument? Dumb. That is a valid argument. It's a valid argument. Now, why? All men are mortal. So if you're a man, then you possess the quality that you are mortal. Mr. Konchak is a man. Bless you. So, that means Mr. Konchak is part of the group they call men, right? And therefore, for me to be a man, I would have to possess the quality that all men do, which is to be mortal. Does that make sense why that's a valid argument? Okay. Is it a valid argument, guys, if I change this a little bit? What if I change this? Oops, that's not going to work. What if I change this to Sally is a woman. Therefore, Sally is mortal. Is that a valid or invalid argument?
Invalid.
Why is this an invalid argument now?
I said it louder. Because Sally is a woman. Sally is not.
No, Sally is a woman. Therefore, Sally is mortal. Do we know anything about women in this particular world?
No.
So therefore, she could be mortal, right? But she also could be immortal. So it doesn't state anything about that group. So if I change it to this, that's an invalid argument.
Yeah.
Okay. Number 2. Hey, we can make these things mathy too.
No. Really?
The sum of the exterior angles in a convex polygon is 360 degrees. I do believe that would be a definition. Definition of an exterior angles of a convex polygon, adding to 360. Triangle ABC is a convex polygon. Therefore, the sum of the exterior angles in triangle ABC is 360 degrees. Is that a valid or invalid argument?
Valid.
Why is it valid?
Because the triangle ABC is a convex polygon, and the sum of the exterior angles of a convex polygon is 360.
Correct. Guys, it states that if you are going to be a convex polygon, then the sum of your angles, exterior angles, will be 360. That's the statement. That's the major universal affirmative. Triangle ABC is a convex polygon. It puts them into the group that has the trait. And so therefore, ABC triangle is 360 because it has the trait then. That is a valid argument. Cool? And the last one for us today. All frogs are green. Henry is a frog. Therefore, Henry is green. Is this a valid or invalid argument? This is also valid. In the real world, are all frogs green?
No.
No. But do I care? No. Because in this particular world, if you are a frog, that means you must be green. And since Henry is a frog, therefore he is green. Okay. Another way to look at this, guys. I'm building a world. There's my world right there. And if in that world, would you agree that there are things called frogs? I put F, an F circle. There's lots and lots of things in this world, but I can lump all frogs into that circle. Do you agree with that, Lucy?
Yeah.
Now, it's saying that all frogs are green. That means if I went, and I'm going to do this in green of all things, if I made another circle for green things, would you agree that F circle, frogs, have to be completely located in the things that are green? So the green circle are all things that are green. Frogs are entirely within that circle. And if Henry, watch this, Henry happens to be a frog, so he's the dot inside of F, which makes him a frog, which also therefore makes him green. Okay? So it works like that, inside to outward, that you're more inclusive as you get closer and closer. Now, could I have stated that Henry is a dog? Therefore, Henry is green?
No, that's invalid.
That would be invalid. Because could there be a circle for dogs over here? That's not, why did I put D for dogs? Where maybe dogs are also green, but since I don't know that, or dogs may not be green. Heck, half the circle could be in and half the circle could be out. There could be green dogs and non-green dogs. Right. So therefore, it would be invalid if I changed to Henry being a dog instead of a frog. Homework's on page 59, day 1, 8, 9, and 26. Have a great day. This has nothing to do with our puzzles or logic questions from today. This is just a few review questions from things in the past. So again, have a great day.